All right, guys. I figured give you a quick video on mutations, just to try to help you out with some things that I feel like some of you were a little bit confused about, and I think some of you came to me today and you were like, "Hey, give me a little more information on mutations." So I figured I'd give you a quick video, just going through the 6 here. I'm going to work with DNA. I'm going to work with mRNA, kind of both, just so you guys can see that you can use both to note what type of mutation it is. The easiest ones, I think, to recognize are the 2 frame shifts. So I'm going to start with those ones. I'm going to go with the DNA. Again, you guys can go with mRNA if you want, but I'm just going to show you how the DNA is going to look differently for these 2 mutations. So I'm going to start with insertion. Here's my original DNA. So this is what I start with. I'm just going to go A, T, T, G, C, G, TAT. Okay? So that's my original DNA. What we're going to have after that is we're going to have some type of mutation occur in order to get some new DNA. So the second one is going to be my mutated DNA. Okay? Now, I'm going to put the mutation in, and then we're going to talk about it. So, there's the mutated DNA. You can see it definitely looks a little bit different. How we can look at these frame shift ones is usually at the end of our strand, things are going to look a little bit different. What I did here, guys, is I did my reading frame for the codons, because we're always going to read these in 3. And then we're going to transcribe them into our codons, into our mRNA, and then we'll make them into our amino acids. But if you notice, all 3 of our codons here are different. We still got the A, we still got the T, but now that T went to an A, and that G went to a T. Everything got screwed up after that first mutation, or that first difference. So if you look here, my A is where everything started at. But let's look a little bit closer. We got ATT, GCG. Well, if we read straight across, ATT, GCG. Everything just, we call it a frame shift because everything shifts down one. We're still going to get 3 amino acids out of this. The T we're no longer going to use in this sequence because, you know, we need 3 to go to an amino acid. But for this one, our whole reading frame got changed. This would have went ATT, we would have did what, A would have went to U, T would have went to A, so we would have had UAA to put into our amino acid chart. For this one, we're going to have A goes to U, T goes to A goes to U, so we're going to have UAU go into it. But this is a frame shift insertion, guys, all right? So that's our insertion, okay? And what we did here is we inserted the A, and that shifted everything else down one, okay? So that's, like I said, a frame shift insertion. And if you guys also notice, all the amino acids with the mutation and after it are all going to change, okay? I'm going to use my same regular DNA strand for this, but we'll do the opposite. We'll do our second frame shift, which is the deletion. So let's do A, T, T, G, G, T, A, T, T. Okay. Now, if you notice here, guys, the ATT is all the same. Everything's cool there. All right. My G matches up, but now the C does not match up with the G. The G doesn't match up with the T. It's all screwed up after that. But if you do look, we got G, C, G, T, A, T. Well, there's the T, A, T, and there's the 2 Gs. But this C right here got deleted when we went down to there. And what that did is that shifted the rest of these to the left. So now we got this GGT here. There's our AT. The A's there, the T's there. And I didn't show the rest of the DNA. Obviously your DNA is going to be more than 9 base pairs long, but I didn't show the rest of it. But we need another nucleotide, another nitrogen base pair, in order to put this into your codon charts. So that T, guys, right there, probably came from DNA a little bit further downstream, okay? So that's gonna be your deletion. And all we did there is delete the C, okay? And like I said, guys, these frame shift ones, this one and this one, are really, really easy to note because everything has changed all the way downstream from where the mutation is. Everything changes. Nothing is going to match up perfectly like that. Instead, it's going to be a little bit that way, or if it's an insertion, it'd be a little bit that way. But you guys can see the whole chain kind of changes for those. All right. Duplication. I'm going to do that one next. We'll do duplication next. These ones are a little bit more difficult, so we'll do them a little bit later. But duplication, again, this one is pretty simple to identify as long as you know what you're looking for. So I'll start off with just a DNA strand. Let's do A, G, A, C, T, T, A, and that's enough. We don't have to go any further than that. I'm going to start off again, that's my normal DNA. For the mutated DNA, I'm going to write that as AAA, GAC, GAC, GTA. All right. Now, looking at our differences in between them, I'm still going to have my first 3 are going to be the same. They're all going to be AAA. Okay. GAC, GAC, that's the same. So everything's good there. Here's where a mutation occurs. T turned into a G, T turned into an A, and then the A turned into a C. Kind of. They didn't really turn into it. Instead, here is where that TTA went. So this ended up going over there. So you can see some similarities, guys, and this is what you want to look at. You want to look at, hey, what's similar and what is different? The GAC is what's different. Okay? We added a whole 3 base pairs, and that GAC is the exact same as the GAC that was in front of it. So if you guys see that, we essentially duplicated the GAC. Okay? So now we got GAC, GAC. That's why we call that one a duplication. Okay? So that's our duplication. Now, let's go to the harder ones. The missense, the nonsense, and the silent mutations. I think silent's probably the easiest out of the 3. So I'm going to start off with a silent mutation. A silent mutation is essentially, you get a loaf of bread, all right? And your mom and dad, they're not up in the morning, so you're making your own breakfast and you just put some toast in the toaster and, oh crap, you just burnt the toast, all right? What you're going to do is you're just going to throw that toast away, and mom and dad don't need to know that you burnt the toast because you got a whole loaf. They're not really going to notice one piece missing. In other words, a silent mutation, guys, is no one really needs to know that something went wrong with this DNA. So again, this is probably the easiest out of our last 3, but for these ones, guys, the mutations aren't going to be as severe as the other 3. So for the DNA, I'm going to put ATG. Let's go with C, C, A, and then A. So that's our normal DNA. Okay. Now I'm going to do the mutated down a little bit more than this one. And we're going to do the mutated as ATG, C, C, T, and A. Okay? So normal DNA, our mutated DNA. let's start looking for our differences here. ATG, that's all the same. C, okay, there's where something went wrong right there. And lastly, AAA, okay, that's all good. What happens for a silent mutation, guys? A silent mutation is we're going to have no amino acid change. Okay? For the nonsense, we're going to have a premature stop codon. Okay? And then missense, it's going to change one amino acid. Okay? So there's our three. And if you notice, for all these ones, stop codon, we got to go to an amino acid to figure out if it's a stop. Silent, we got to go to an amino acid to see if there's no change. Missense, to see there is a change, obviously, we're still going to have to go to an amino acid. So what we got to do for these ones, again, the frame shift ones and duplication, they're real easy to spot because we can look at the DNA, we can look at the mRNA, we can see if everything shifts or we can see if something duplicates. But for these ones, we got to go to the amino acid. So let's go to the mRNA first for each of these. A goes to U, T goes to A, G goes to C, and just finishing the rest of it, GGU, and then UUU. I'm going to do the same down here. I'm going to go to my mRNA for this. A is going to still go to UAC there. This one's going to go to GGA, and then we're going to still stay with UUU. Okay? If you guys get out your little codon charts, you can see that UAC goes to TYR, GGU goes to GLY, and then UUU goes to PHE. Okay? Without even looking at the chart, I got UAC here, I got UAC here. Sorry, I've got the right amino acids here. Okay. We're still going to go to TYR here. We know at the end we're still going to go to PHE, but this is the one in question because this is where our mutation happened. So this is where, right here in the middle, guys, this is going to determine if it's going to be a missense, a nonsense, or a silent. So we got the GGU going to GLY. Now if you look at your charts, GGA also goes to GLY. There was no change in our amino acid, even though the A is now a T. So that one, guys, this is going to be our silent mutation because the amino acid did not change. Okay? So that's your silent mutation. So again, for these three guys, you got to go all the way to the amino acids. That's why they're a little bit harder to identify than the frame shift or the duplication. All right. With the same thing in mind, guys, I'm gonna just change some things here, and we'll do the other two. Okay. So I'm gonna keep my template strand. My original DNA, I'm going to keep that the same, but let me mutate things a little bit differently down here. So we'll go to, let's start off with A, T, C, and then we'll go C, C, A, and A, A. Okay. So looking at these guys, you know these here are the same. These here are the same. Let's pinpoint our mutation where that happened. So that's going to be right here. The G now went to a C. Okay. So again, it's not a frame shift. It's not a duplication. There's nothing duplicated. There's only one base pair that changed. So let's go to our mRNA first. It's going to be U, A, C, G, G, U. These two will be the same here. These two codons, and then it'll be U, A, G. Okay. All right. So for this one, guys, I got my mRNA up here. Everything's good there. So let's go to our amino acids. And UAC, that's going to go to UAC. That's going to go to TYR. GGU, that's going to go to GLY. And then UUU, it's the one we did last time, that's going to go to PHE. Okay? So I'm going to see what happened with this one first. On our mutated DNA. So we're going to start with the UAG. UAG, it goes to TER, but TER is one of our weird ones. It is a stop codon. So right at the beginning, it mutated, so we have a stop. So everything after this is actually not going to get translated. The mRNA is not going to get translated to the amino acid because we got that premature stop codon. So this kind of mutation is called a nonsense, all right? And the stop codon, guys, could be at the beginning, it could be at the middle, but the only time it's not a nonsense one is if it's all the way at the end. It's not a big deal if it's at the end, okay? But if it's anywhere in our whole chain except for the end, it's a nonsense, all right? So that's that one. Okay. Last one we gotta do is missense. So let me erase all this one more time. Okay. So what I'm going to do here is I'm going to keep the first one the same, ATG. We'll go with CCA there, and then we're going to go with A. Let's go with T. Okay? So I kept the first one the same, everything's good there. I kept the second one the same, everything's good there. We got the A, but here is our mutation right at the end. Instead of it being an A, it now went to a T. So let's go to our amino acids first. ATG, it's going to go UAC, GGU, UUU again. If we want to go to our amino acids, just because we've done this a good bit, UAC is going to go to TYR, GGU is going to go to GLY, our amino acid, and then UUU is going to be, once again, PHE, right? Working down at the bottom, this is still going to be UAC, this is still going to be GGU, everything's good there, but this one is no longer going to be UUU, it's going to go to UUA, okay? Going to our amino acids, this one's still going to be TYR, this one's still going to be GLY, UUA, let's put into our chart, UUA, it goes to LEU. So at the beginning, we had PHE before our DNA mutated, but afterwards, now the PHE went to LEU. So we had one amino acid change. It's not like a frame shift where it affects all of them. This one only affected one of them, okay? So that's why this one is called a missense. All right, so there's your 6 types of mutations, guys. I gave you examples of each one of those. Hopefully this helped you guys out. Hopefully you'll be a little bit better prepared for your test. All right, guys, have a good rest of your day.